disagree with that. Because I forgot my phone in church and I didn't have it. So that was an hour. Okay, so we're going to start with the FTC. Which is the fundamental theorem of calculus. Okay, you guys remember this? The integral from A to B, and then we don't have to do that in this class. If you want to look at the video from the other class, we talked about U substitutions and all the functions you can integrate. But we can do that in this class too. But if you have f of x dx, okay guys, the fundamental theorem of calculus says, we're going to put that away and we're going to do math. If you try, even next week, to try to review everything, it's going to be really tough. You need to be doing it now. Should have been doing it since we got back from break. It's any antiderivative evaluated at B minus any antiderivative evaluated at A. That's the fundamental theorem of calculus. Hopefully you know that. So I'm going to give you this. What if I have the integral from A to B of f prime of x dx? What's the antiderivative of f prime? It's little f of x. So it's little f of b minus little f of a. They do that often. Okay, so they might call it f prime. Well, then you say it's going to be f. Well, how do they use this theorem? They might say we have a point that goes through 0, 5, and we want to integrate. We want to find out what happens at 10. Okay, so they're going to give you a function, and they're going to say find the value of that function at t equals 10 or x equals 10, and they give you a point, an initial condition. So it's going to be 0, and it's going to be f prime of x dx. They're going to give you the derivative, and then I'm going to put in 10 here because that's equal to f of 10 minus f of 0. I get an equation. And what they're going to do with this integral is either you could integrate it by hand, possibly. It might be a calculator. I've seen them do problems where one of them's with a calculator and the other one's with geometry, all in the same problem. Rest assured, you will see the geometry. You will see the calculator part. So it's geometry. So maybe it's a circle or a line or whatever. So you can find the area under that curve easily with geometry. Or they might have you integrate e to the negative 4x or something, who knows, something like that. Or you could do it by hand. So these are the types of things you're going to have, and that's going to be equal to f of 10 minus f of 0. So to find f of 10, it's equal to f of 0 plus this integral. And you've seen that several times. It's usually the last or second to last question in a free response problem. Okay? So, and that you will see that on the 2012. I think it's number 1. I don't have them memorized, so I don't know. But you'll see that concept. I guarantee you'll see that concept. Any problems with the fundamental theorem of calculus? Integral of a f prime gives you f. Yes? No, because I added f of 0 to both sides. So some of you go right to this line, and that's fine, because that's how they do the scoring rubric. You start with your initial condition, and you add in that. So if your initial velocity is 15 miles per hour, you'd have 15 plus, and then whatever you would accumulate after that. So you have to read the question carefully. I've seen that in multiple choice questions where you forget to put the initial condition in. But the fundamental theorem, if you actually follow through on it, will always do that. Then we have the second fundamental theorem of calculus, and that's the derivative of the integral. Do you remember this one? Whoops, that's not f of t. Sorry, excuse me, that's x. We'll do them all. And that's f of t dt. It always has to go from a constant to a variable. And you're taking this is a function. Let's pretend we know how to integrate f of t. Okay, so we know how to do that. Why I would want to do that when it's asking for the derivative back again, it seems like a lot of work. Because I'm going to integrate it and then I'm going to differentiate it, d dx. And then let's say the antiderivative is capital F. So it's f of x minus f of a. I'm doing this quickly because we've done this before. What is the derivative of that? What's the derivative of f of x? Little f of x. What's the derivative of a constant? 0. So this is equal to f of x. The easy way to do it is to take x and just put it in there. Sometimes you can't integrate it anyway, so you have to know this theorem. But if you can understand this, if you understand why it works, then you remember it. So what if I have d dx, and this is backwards? What if I go from x to a? What's going to happen to my antiderivative? What's going to happen to this piece? It'll be backwards, and it's subtraction, not commutative. So this is negative f of x. There are some things you must memorize. This is one of them. And what if I have the derivative with respect to x of the integral of a to g of x of f of t dt? Remember that one? I have to do the chain rule. So it's f of, and you have to put g of x in here. So it's f of g of x times the derivative of the upper limit, g prime of x. If you think about it, why would you have to do that? Because it's the derivative. We anti-differentiate this as capital F of g of x minus capital F of a. And when I differentiate capital F of g of x, then I have to find the derivative of f of g of x, but I also have to multiply it by the derivative of the inside function. And I can do that here. What is the derivative of x with respect to x? It's 1. Whatever works here has to work in the simple case, and it does. Okay? You're going to see this with area problems. They're going to define g of x, something like this, as the integral from 0 to x of f of t dt. And they might ask for g of 0. What's g of 0? Remember that? I think I'm reviewing it. It's 0. They might ask for g prime of 2. Then you would find, first off, you'd find g prime of x, and you can't see it because it's up here too high. What's g prime of x? I'll take the derivative with respect to x of both sides. What is g prime of x? It's just f of x. So what's g prime of 2? It's f of 2. I believe question 3 has that in this. Question 4 is just a straightforward calculus problem. Find the derivative, find the equation of the tangent lines. It's really straightforward. So you're going to see this too. That's the second fundamental theorem. And you need to practice so that when you run into it, you'll know what to do. At least that's my feeling on it. Now, let's do one more that's on here. So try this one. This husband wrote this up, but she didn't put an answer down. Okay, so we're going to find the derivative of the integral. And I think, when you get to the problems on the free response, where you have to find g prime of x, if you actually write it out, the derivative with respect to x on both sides, it'll click that I got to do that fundamental theorem. Okay, so how do I do this? Zach, do you know? Yeah, you put 3x squared in for t here and for t there. I can't even integrate this. It's not even possible. So it's the ln of 3x squared times the sine of 3x squared. That will be one answer. Not all of them, but that will be an answer. What's still missing? I need the chain rule, so I need to multiply by the derivative of this, which is 6x. Yeah, that's easy to forget. That's why you want to do problem after problem, check them with the scoring rubrics until you start feeling secure. Even then, when you walk into that exam and you look at the problems and they're all different, you're going to say, oh my goodness, I didn't prepare for this. Yes, you did. You just have to stop, read the question and say, oh, that's just the bird problem, or that's just whatever we did, the concert problem, or maybe it's the elephant problem. You're going to have to read the problems. They might put a little different spin on there, but basically the concepts are going to be the same. Now, we did use substitutions in the other class. It's not really on the schedule, but do you want to go through all the functions you do know how to integrate? Might as well do the same thing. So here's your function. I'll do it a little more organized than I did on the last one. And the antiderivative. You have this in that ivory packet. And I thought I had extras here. It's at the very end of it. And I'm going to tell you right now, because of the fact that I'm doing study sessions at night, I'm a little behind in my paperwork. I'm trying, but you know, when I'm here for 3 hours and it's the extra commute, because I don't live that close. This packet has almost everything. I don't know if everything's in it, but it's got a lot of good stuff in it. But on the very last page, these are the functions you know how to differentiate and integrate. You need to know this. Okay, so if we do x to the n, what's the antiderivative of that? X to the n plus 1 over n plus 1 plus c. Now, these are the only ones we can integrate. So if it doesn't look like one of these, then we do a u substitution to make that happen. Now, when do I use this power rule? N is any number except what? Except -1. Could it be -2? Yeah. But for some reason, when you look at 1 over x squared, you think of that as a natural log. That's not true. That's this. It's x to the -2. And natural log will be one of the choices. And this is x to the -1 over -1 plus c. Yes? We just ignore the constant. It's still there. But we ignore it. Remember, we passed that through the operator. So I actually want to link these two together because they are together. What if x is -1? What if you have x to the -1, which is 1 over x? What's that one? So this takes care of all the powers. Okay, Zach? It's all the powers. The log is only when it's 1 over x to the first power, not second. So it's the log of the absolute value of x. Don't forget the absolute value. Because if you forget the absolute value, we're going to lose solutions. Okay? So it's 1 over x squared. That doesn't look like 1 over x. It must be exactly identical. How about a twin? Does that work? If it's 1 over x plus 1, you're right. I could do a u substitution just to prove it. U is equal to x plus 1. Then du is equal to dx. So this would become the integral of 1 over u du. So yes, can I make it look like just 1 over x? I can. Now, if it's going to be, and I've seen this happen, if it's the integral of 1 over 1 minus x, we have some problems here. It's still going to be the log, but the problem's going to be that minus. How do you know a function's an antiderivative? Take the derivative of it. So if I let u equal 1 minus x, you're going to see what's going to happen. What's du? Negative dx. Well, I've seen this many times on the exam in the free response. That's the reason why I'm going over it. Maybe it's 300 minus x. I don't care what it is. So then this is negative 1 over u du, which is negative natural log of the absolute value of u plus c. Do you see where the negative's coming from? And here's the other issue. If I have e to the negative natural log of x, is that equal to negative x? I'm tempted. I want to do that myself. But is it true? No. E to the just plain log of x is equal to x. So what if you have that negative there? You can do e to the log of x to the -1. Those are properties of logs. Then that would be x to the -1. Well, before I would, in the middle of the differential equation, I would divide by -1, get rid of it. That's easiest. But this works too. Yeah. And why do I bring that up? Because I graded that problem, and I saw this so many times. So many times I saw that. Very consistent. The other thing I've seen is e to the x plus the log of 2, for instance. We'll write it as e to the x plus the log of 2. Is that true? No. I saw that in today's quiz in the previous hour. Okay, so I don't want to see I still see it today. I'm hoping not. Leave it like that, because we don't ask that you simplify it. But if you want to, this is e to the x times e to the log of 2. And e to the log of 2 is 2. So that would be 2 e to the x. But this is just fine. We don't care. So better to not simplify if you don't know what you're doing. You may think you know what you're doing. Still better not to simplify. Okay. That's all the log stuff. And you know there's going to be a log and an exponential. What's the integral of e to the x then? E to the x plus c. Now, what about the sine function? Negative cosine of x plus c. What about the cosine function? Sine of x plus c. Now we're going to get some trickier ones. I'm just going to extend my page here. What if, okay, we could do a to the x. I forgot to do that one. Yeah, well, the derivative is my name, but the integral is a to the x divided by the natural log of a. Notice there's no chain rule in these. You have to do a u substitution to figure out how to undo the chain rule. It's the only way to do it, or else think through it, and that's harder. What about secant squared? Remember that one? Tangent. Very good. What about cosecant squared? Well, if secant is tangent, then cosecant is cotangent, and all the cofunctions are negative. Keep that in mind. Cofunctions are negative, yes. Oh, I gotta watch my time. Okay, what about, I don't know why I feel like I'm behind. Okay, what about secant tangent? Secant. You may see those. If you see these, you're going to see them on the multiple choice, I believe. What about cosecant? This is how I remember it. I know some of these. I know this one, so this one's just like that. Well, it's secant, tangent, secant. So cosecant, cotangent is cosecant of x. It's negative plus c, because the derivative, all the known cofunctions are negative. Did I get them all? What about 1 over the square root of 1 minus x squared? Remember that one? Inverse sine. You will see that in the multiple choice. You won't. I don't think you're going to see them all. If there's a negative there, and it's in the multiple choice, you might have to know that that's equal to the inverse cosine of x. You don't have to know those. You would do a u substitution. We could do that. 1 over 1 plus x squared is what? Inverse tangent. So what if I wanted to integrate the tangent of x? Now, you are not going to integrate the natural log of x. If you do, it'll be calculator, because I need integration by parts, and that's not in this class. Well, tangent is sine of x dx over cosine of x. And you have 2 different u substitutions you can use, but only one is going to work. If u is equal to the sine of x, then du is equal to the cosine of x dx. I don't have that. I have sine of x dx. See where the problem is? That was a good guess. It's not going to work. We want, no, that it's not the sine of it. It's the fact that this is in the wrong place. The cosine's in the denominator in my problem. So if I let u equal the cosine of x, then du is equal to negative sine of x dx. Well, negative's not that big a deal. Okay, so I'm going to put a negative here. Sine of x dx is replaced by du. And then this is 1 over cosine. Well, that's 1 over u. What is that one? Didn't recognize it until I did the u substitution. natural log of the absolute value of u. You could memorize this if you want. I don't think they're going to ask this. Yes. Well, one at a time. Indefinite integral. I don't have any. If it were, then I'd have to change there wouldn't be a c, and I'd have to change the limits of integration. Yeah, it's in my other video, and I think I'm going to run out of time. What's u here? Absolute value of cosine of x. I know. Okay? You're not, they shouldn't ask you, but if you do have to do it, you just do a use substitution. What if they had you do this from 0 to pi? No. Now, you guys, you'd have to change the limits of integration because they could ask you just to set it up. And so if x is 0, what's the cosine of 0? 1. So that would be 1. Once I change over to u's, I got to change it all. And then if x is equal to pi, what's the cosine of pi? Do you remember that one? No, it's not 0. Negative 1. And there you go. Okay, spread yourselves out so you have enough time.